boys. In this video, let me see an example under odd and even functions in Fourier series. For that, here I am going to take an example. Expand f of x is equal to pi minus x the whole square as a Fourier series in an open interval minus pi comma pi. Before let me enter into the problem, let me have a short look over the formulas that we are going to use in the problem to find out the Fourier series representation of the given function. So, first important formula you should know is Bernoulli's formula. That is, whenever you are having product of two functions inside the integration, to make use of this formula gives you the result of the integral. Okay, to get the integral value, we make use of this formula. That is, integral u v dx is equal to u v1 minus u dash v2 plus u double dash v3 minus etc. Here both u and v are functions of x. Here u dash, u double dash, u triple dash etc. representing successive derivatives of u, which means u dash means you have to differentiate u once with respect to x, u double dash means you have to differentiate u twice with respect to x etc. And v1, v2, v3 are successive integrals of v. So v1 is nothing but you have to integrate v once with respect to x. v2 is integrating v twice, already we integrate once, so you have to integrate v1 only once, means that is v2. v3 is you are going to integrate v 3 times, already we integrate 2 times, so you integrate that once again, that is your v3. So u dash, u double dash, u triple dash etc. are successive derivatives, whereas v1, v2, v3 are successive integrals of v. The next one, basic formulas of integration and differentiation, as you know already. That is, integral x bar n dx is equal to x bar n plus 1 divided by n plus 1, whereas d by dx of x bar n is equal to n x bar n minus 1, and integral sin n x is equal to minus cos n x by n, and integral cos n x equal to dx is equal to sin n x divided by n. And the value for cosine 0 is 1, and cos n pi is equal to minus 1 whole power n, sin 0 is equal to 0, and sin n pi takes the value 0 for all integer value. Here we have to take the values of n in terms of integers, so the value of sin n pi is 0. Next, some of the points you should remember. Here the first one is integral from minus a to f of x dx is equal to twice integral from 0 to a f of x dx whenever f of x is an even function. If f of x is an even function, you can immediately write this integral as twice integral from 0 to a f of x dx. Okay. Suppose if the function f of x is an odd function, directly you can write the value of the integral as 0. And the product of the second important point you should remember is product of even and even function gives you an even function. Odd and even function product gives you an odd function. Even and odd function product gives you an odd function, and odd function product gives you an even function. Let me now enter into the problem. Expand f of x is equal to pi minus x whole square as a Fourier series in an open interval minus pi comma pi. This is what the given problem. First we have to find out what is given. So given f of x is equal to pi minus x the whole square. That is given in the interval, open interval minus pi comma pi. Listen carefully. So you have to write out the function along with the interval, that is very must. Okay. So look at the interval. As I told you already at the beginning of odd and even function introduction, the case for odd and even arise only for the intervals of type minus pi comma pi and minus l comma n, and not for the intervals of type 0 2 pi and 0 2l. So the case of odd and even arise only for these two intervals. For more details, the link is given in the description. Refer the link for more details. Okay. So the cases for odd and even arise only for these two intervals. Here, look at here. Our given function is in the interval minus pi comma pi, which means we have to verify whether the given function is of odd or even. So for that, what we do? Just replace x by minus x in the given function. If replace x by minus x, what happens? Pi minus of, if replace here x by minus x the whole square. Pi minus of minus x is nothing but pi minus and minus becomes plus pi plus x the whole square. Look at the given function and here too. So this is pi plus x the whole square. Given function is pi minus x the whole square, which means f of minus x is not equal to f of x, isn't it? This is not the given function. The second condition, what is the second condition we have to verify? If it is equal to minus of f of x, no. So we have two conditions. Whether the given function, if you replace x by minus x, that gives you the same function, means f of x even. Okay. If you replace x by minus x in the given function, if you get minus of f of x, means that is an odd function. So here this function is not equal to f of x, that is this value of the function is not equal to f of x, and this is not equal to minus of f of x too. So which means what is our conclusion? Therefore f of x is neither even nor odd. It is not an even function and also an odd function in an interval, given in an interval minus pi comma pi. So in that case, we have a separate formula for calculating the values of a naught, an and bn. So I list all the formulas here. So leave the pi formulas are 0 to 2 pi. Here we are dealing with the function in the interval minus pi comma pi. Minus pi comma pi, we have three cases. If it is even and odd, neither are even nor odd. So we are under this case, isn't it? If it is neither even nor odd, we can calculate the values of a naught, an and bn. For that we make use of these formulas. Okay. So now let the required Fourier series be of the form, let f of x is equal to a naught divided by 2 plus sigma n varies from 1 to infinity an cos n x plus sigma n varies from 1 to infinity bn sin n x. You take this as equation number 1, where a naught is calculated by making use of the formula 1 by pi integral from minus pi to pi f of x dx, and an is equal to 1 by pi integral from minus pi to pi f of x cos n x dx, and bn is equal to 1 by pi integral from minus pi to pi f of x sin nx dx. You take this as equation number 2 and this as equation number 3 and this one as equation number 4. So after calculating a naught, an and bn, we substitute all these values in equation 1, use the Fourier series representation of the given function f of x in an open interval minus pi comma pi. Let me start our calculation. So first we calculate the value of a naught. So from equation 2, we have the formula for calculating a naught as a naught is equal to 1 by pi integral from minus pi to pi f of x dx. Just replace f of x by the given function. Here the given function is pi minus x the whole square. So there are two methods for solving, to find the solution for a naught. Either you can take the integral limit as it is, you proceed by integrating this pi minus x the whole square, and after substituting the limits you get the answer. And the other way is, what I am going to do is, that's an easiest way, that is, hope so, pi minus x whole square is of the form a minus b the whole square, isn't it? It is of the form a minus b the whole square. What is the formula for a minus b the whole square? A square plus b square minus 2ab, isn't it? This is of the form pi minus x the whole square is of the form a minus b the whole square, and just expand. So a square plus b square minus 2ab, isn't it? So I am going to do like this, that is 1 by pi integral minus pi to pi square plus x square minus 2 pi x dx. Just separate the integral, okay? 1 by pi, first integral is minus pi to pi square dx. Second one is 1 by pi minus pi to pi x square dx. The third one is minus 1 by pi integral from minus pi to pi 2 pi x dx. So what I am going to do next is, I am just use the concept of integral property. That is what we see already. So here look at the integral from minus pi to pi. So what is the function inside? So if pi square is constant, you only have constant. Constant means whenever you replace constant by any value of x, it doesn't change. So I am going to write this as twice integral 0 to pi So I'm just take pi square or write pi square inside. Okay, no problem. The next step I have to take it outside. Okay, so don't confuse this. So I just write twice 0 to pi square dx, isn't it? That is, it will, or in other words, I have to take this as an even function. The next one is 1 by pi. Look at the interval minus pi to pi. Here the function inside here is you have x square. X square is an, look at the power, 2. So if you replace x by minus x, you get the same function. So I can write that is an even function means immediately you can write integral minus pi to pi as twice integral 0 to pi. Already you have pi in the denominator. So x square dx minus, coming to the next. Here you have x, 2 pi is a constant having power 1. So if you replace x by minus x, what happens? You get an odd function. If it is an odd function, immediately that becomes 0, isn't it? Since the limit is from minus pi to pi, that becomes 0. Next, what I am going to do is, one of the pi being cancelled, so that is equal to 2 pi integral 0 to pi dx. Next one is plus 2 by pi integral 0 to pi x square dx. So in your next step, I am just go to the next step. So here a naught is equal to 2 pi, a naught is equal to 2 pi integral 0 to pi. I am just writing the previous step once again. So 2 pi integral 0 to pi dx plus 2 by pi integral 0 to pi x square dx. 2 by pi integral 0 to pi x square dx. Now integrating, that is 2 pi integrating dx, you get only x with the limit from 0 to pi plus 2 by pi integrating x square, you get x cube divided by 3 with the limit from 0 to pi. So now let me substitute the limit, upper limit minus lower limit, that is pi minus 0 plus 2 by pi. Here itself we have to substitute the limits, that is pi cube divided by 3 minus 0 cube divided by 3, that is equal to 2 pi. Pi minus pi is nothing but pi itself, isn't it? Plus 2 by pi. Here 0 cube by 3 is nothing but 0 itself. Here you get only pi cube divided by 3. That is equal to 2 pi square plus here one of the pi being cancelled. So here itself you get 2 pi square divided by 3. Take an LCM as 3, what you get? So 3 2s are 6. So 6 pi square plus 2 pi square divided by 3, that is 8 pi square divided by 3 is the value of a naught we have calculated. So the value of a naught we have calculated is 8 pi square divided by 3, isn't it? Next we calculate the value of a n. So from equation 3, we got the formula for calculating a n is 1 over pi integral from minus pi to pi f of x cos n x dx. Just replace the function f of x by 1 over pi integral from minus pi to pi. Your f of x is pi minus x the whole square cos nx dx. So one of the ways for calculating the value of n is you just take the given function. This is u and v, and you can proceed by substituting limit minus pi to pi. So the other way is what I am going to do is I am just expand this and find out which of the function is odd or even. Based on that I am going to calculate the remaining value. Okay, so that is what the easiest procedure too. So 1 over pi integral from minus pi to pi, expand this, what you get? A square, that is pi square plus x square minus 2 pi x cos nx dx. So now separate the integral, that is the first integral consists of only pi square alone, isn't it? Pi square cos nx dx. The second integral plus 1 over pi integral minus pi to pi x square cos nx dx. The next one is minus 1 over pi integral from minus pi to pi 2 pi x cos nx dx. Now what I am going to do is look at the integral and check which of the integral is odd or even. Based on that we can convert this integral from minus pi to pi as twice 0 to pi or 0 directly. Okay. So here pi square is a constant limit. So cos nx is an even function, isn't it? So you can write this integral as twice 0 to pi and you can evaluate the integral. Okay. Next look at here, x squared is an even function, cos nx is an even function. So this is even, x square is even and cos nx is even. Product of two even function gives you an even function. So immediately you can write this minus pi to pi integral as twice integral 0 to pi, and you can calculate the value of this integral. Look at the third one. So look at here, 2 pi is a constant. So here you have x cos nx. X is an odd function, isn't it? Cos nx is an even function. Product of odd and even function gives you an odd function. So the value of this integral you can directly write it as 0. So in the next step, first two integral only exists, the third one becomes 0 because that integrand is odd. Okay. So next one is an, that is equal to, I am just write it twice 0 to pi. Inside the integral you have pi square cos nx dx. Okay. Pi square cos nx dx. Plus the second integral also I am going to write as twice integral 0 to pi. So already in the denominator you have pi. So I just replace this integral to twice 0 to pi. X square cos nx dx. Okay. So x square cos nx dx. The next term becomes 0 because the integrand is an even function. Now let me integrate this. So pi square is a constant. So one of the pi being cancelled and take it outside of the integral. So here you get 2 pi. So only 0 to pi cos nx dx alone. Plus here 2 by pi. Sorry. Integral from 0 to pi x square cos nx dx. So now what we are going to do, just integrate as usual. So 2 by pi integrating cos nx you get minus sin nx divided by n with the limit from 0 to pi plus 2 by pi. This is a product of function, so you take the first one as u, second one as v. So as usual you know the formula already, isn't it? u v1, that is x square, v1 is nothing but integrate cos nx you get sin nx divided by minus u dash, that is 2x. When you integrating cos and sin nx you get minus cos nx, already you have n in the denominator, so n square, plus differentiating 2x, that is u triple dash. U triple dash is, this is double dash, 2x, that is 2 itself, minus 1 by n square is constant. So integrating cos nx you get sin nx, already you have n square in the denominator, so that becomes n cube with the limit from 0 to pi. Okay, so if you don't know how to integrate this, okay, directly by making use of the formula, just write u is x square. So what is your u dash? 2x, u double dash 2, u triple dash 0. So leave this, and your v is cos nx. v1 is integrating cos nx you get sin nx by n, and v2 is integrating sin nx you get minus cos nx, already you have n in the denominator, so n square. And v3 is minus 1 by n square is constant, integrating cos nx you get minus of sin nx by n cube. That's all. So that's equal to 2 by pi. So look here, let me substitute the limit. If you substitute the upper limit, what happens? Sin n pi. You know the value of sin n pi, 0. Minus coming to the lower limit, sin 0. That is 0. So this term doesn't have any value. Coming to the second term, 2 by pi. So substitute the limit first, pi. So if you substitute the limit pi, sin n pi, first term becomes 0. Minus, here 2 times pi, cos n pi value you know, minus already you have. The value of cos n pi is minus 1 whole power n divided by n square. Plus coming to the third term, sin n pi. If you replace this x by 0, you get 0. So coming to the lower limit, upper limit over minus lower limit. If you replace x by 0, what happens? First term 0. Coming to the second term, if you replace here x by 0, second term 0. Plus if you replace x by 0 in the third term, sin 0, 0. So that's all. So there is no value for the lower limit. So 0 plus 2 by pi. Here these two minus becomes positive. So you have 2 pi minus 1 whole power n divided by n square. This pi cancel. So you get 4 pi minus 1 whole power n divided by n square. So this is the value of an. Next, sorry, not pi, 4 times, pi cancelled, isn't it? 4 times minus 1 whole power n divided by n square. This is the value of an we have calculated. Next, we calculate the value of bn from equation 4. We have the formula for calculating bn as 1 over pi integral from minus pi to pi f of x sin nx dx. Replace f of x by the given function pi minus x the whole square sin nx dx. As usual, as I told you already, you can proceed by taking this function as u and this one as v and taking the limit as it is. You can find the value of bn. The other way is simple way of calculating the value of bn by making use of the odd and even function concept is, so 1 over pi integral minus pi to pi, expand this, so pi square plus x square minus 2 pi x sin nx dx. So split this integral into 3, that is 1 over pi minus pi to pi, pi square sin nx plus 1 over pi integral minus pi to pi x square sin nx dx minus 1 over pi integral minus pi to pi 2 pi x sin nx dx. Look at here, pi square is a constant in the first integral, pi square is a constant, sin nx is an odd function. So value of this integral is directly put 0. Coming to this again, x squared is an even function, sin nx is an odd function. Product of even and odd function gives you an odd function. So the value of second integral also 0. Coming to the third integral, 2 pi is a constant. So x is a odd function, sin nx is a odd function. Product of odd and odd function gives you an even function. So this integral alone exists. So you can write here minus pi to pi integral as twice 0 to pi. So we have the last integral alone. So bn is equal to, first integral becomes 0 because the integrand is an odd function. Second integral becomes 0 because the integrand is an odd function, minus here 1 by pi minus pi to pi. So here minus pi to pi integral can be written as twice integral from 0 to pi. So already you have pi in the denominator. 2 pi x sin nx dx. 2 pi x sin nx dx. So one of the pi being cancelled. So you have 2 is a constant, take it outside, minus 4 times integral 0 to pi x sin nx dx. This is product of functions of the form integral u v dx. So we make use of the Bernoulli formula. So here your u is x, so u dash is 1. So you don't have after u dash because u double dash becomes 0. So your v1, I am just write first v is nothing but sin nx. What is your v1? Integrating sin nx you get minus cos nx divided by n, and v2 is minus sin nx divided by n square, isn't it? Minus 1 by n is constant. Integrating cos nx you get sin nx by n. Already you have n in the denominator, so n square. So u v1, what is the formula? U v1. U is, this is your u, this is your u is x. v1 is nothing but minus cos nx divided by n, minus u dash v2. What is your u dash? 1. v2 is nothing but minus sin nx divided by n square. That's all. With the limit from 0 to pi. Let me substitute the limit. First upper limit. If you substitute the upper limit, what happens? Upper limit minus lower limit. Bracket is very must, okay? So if you replace x by x pi, what happens? Pi minus of, you know the value of cos n pi. What is the value of cos n pi? Minus 1 whole power n divided by n. Minus, coming to the second term, sin 0. You know the value of sine 0, that is 0. Minus, coming to the lower limit, if you replace x by 0, what happens? The first term becomes 0. So 0 minus, here the value of sine 0 is 0. So there is no lower limit value. So here minus and minus here becomes plus 4 pi minus 1 whole power n divided by n. This is the value of b and we calculated. Now substitute all these values. Substitute these values in equation 1. We get the Fourier series representation of the given function. So your first equation is f of x equal to a0 divided by 2 plus sigma n varies from 1 to infinity an cos nx plus sigma n varies from 1 to infinity bn sin nx. So the value of a0 you calculate as 8 pi square divided by 3 whole divided by 2 plus sigma n varies from 1 to infinity an. An value we calculated as 4 times minus 1 whole power n divided by n square cos nx plus sigma n varies from 1 to infinity. Your bn value is 4 pi minus 1 whole power n divided by n sin nx. So here 4 2s are 8, isn't it? And the second term 4 is a constant, take it outside of the summation. Here itself 4 pi is a constant, so take it outside of the summation. So your f of x is 4 pi square divided by 3 plus 4 times sigma n varies from 1 to infinity minus 1 whole power n divided by n square cos nx plus 4 pi sigma n varies from 1 to infinity minus 1 whole power n divided by n sin nx. So this is what the Fourier series representation of the given function f of x is equal to pi minus x whole square, that is defined in an interval minus pi comma pi. So the Fourier series representation of the given function we have calculated by making use of the concept of odd and even function, since the function given in an interval is of type minus pi comma pi. Okay. Hope you got a clear idea about the concept of odd and even function. Thanks for watching. See you all again in my next video.